Linear programming examples.
Linear programming. Let's have a look at an example. 540 football supporters are going to an away match. They want to hire either coaches or minibuses. Now, a coach can hold 50 people and a minibus can hold 20 people. There are a maximum of 11 coaches and 14 minibuses available. In part 1, we are asked to write down 5 inequalities and represent this on a graph. Now, to do this, let C and M be the number of coaches and minibuses. Now, obviously, we can't have a negative number of vehicles, so M is greater or equal to 0 and C is greater or equal to 0. Now, the maximum number of coaches is 11, so C is less than or equal to 11. The maximum number of minibuses is 14, so M is less than or equal to 14. Now, the total number of passengers that can be carried is 50 per coach and 20 per minibus. Now, that's got to be enough to carry 640 people. So 50C plus 20M must be greater or equal to 640. We can divide all the way through by 10, and that gives us 5C plus 2M is greater or equal to 64. Now we need a graph grid where C lies between 0 and 12 and M lies between 0 and 15. And the first thing we do is we shade out the negative values of C and M. This is because we have C is greater or equal to 0 and M is greater or equal to 0. Now we want to draw the graph of C is less than or equal to 11. To do this, we draw the graph of C equals 11. This is a vertical line crossing the C axis or the x-axis at 11, and we have to shade out the region where C is above 11, that is, to the right of the line. Then we want to draw the graph of M is less than or equal to 14. So we draw the graph of M equals 14. This is a horizontal line crossing the M axis at 14. Now we want to shade out the region above the line because we want to shade out the region where M is greater than 14. And finally, we want to draw the graph of 5C plus 2M is greater or equal to 64. To do that, we first draw the line 5C plus 2M equals 64. Now to do this, choose some points. If C is equal to 10, then we have 5C, which is 50, plus 2M equals 64. So 2M is equal to 14, which means M is equal to 7. And so we plot the point 10, 7. If we choose C as 12, then we have 5C, which is 60, plus 2M equals 64, which means 2M is equal to 4, and so M is equal to 2. And we plot the point 12, 2. We join the points with a straight line. Now we need to find out which side of the line to shade. So we choose a point not on the line. Let's suppose we choose the origin, which is 0, 0. We substitute that in the inequality 5C plus 2M is greater or equal to 64, and that gives us 5 times 0 plus 2 times 0 is greater or equal to 64, which means 0 is greater or equal to 64, which is false. So we shade out the side which is false, and in this case we shade out the side of the origin. Now in part 2, we want to know what is the minimum number of vehicles needed. Well, if we let T be the total number of vehicles needed, we have M plus C equals T. This is called an objective function. For different values of T, we get different lines, but they form a family of lines, all parallel to each other. Now, to find the minimum value of T, we draw the graph as close as possible to the origin. So we start with the equation m plus c equals 0. And we slide the graph away from the origin until we come to the first point inside the unshaded region. This is the point 11,5. So for the minimum number of vehicles we have 11 coaches and 5 minibuses. This means the total number of vehicles is 16. Now in part 3 we're asked if a coach costs £300 and a minibus costs £100, what is the cheapest way of travelling? Now we want to find the minimum price. Let P represent the total price. So we have the total price is £300 per coach plus £100 per minibus. So 300C plus 100M is equal to P. This is another objective function. Now to find the minimum value of P, we draw the graph of 300C plus 100M equals 0, and we slide the graph away from the origin until we get the first point inside the unshaded region. Now that occurs when C is equal to 8 and M is equal to 12. So the cost is 8 times 300, which is 2,400, plus 12 times 100, which is 1,200. So the total price is £3,600. Let's have a look at another example. On a club trip to an exhibition, there must be at least one adult for each 3 children. Tickets cost £2 per child and £5 per adult. The club has £90 to spend. Draw a graph and represent this. What is the maximum number of people who could go? Well, to solve this, let x be the number of children and y be the number of adults going. And let's shade out any unwanted regions. Now we have the following equations. X is greater or equal to 0 and y is greater or equal to 0. Now there must be at least one adult for each 3 children, which means x is less than or equal to 3y. Now the cost of tickets will be £2 times the number of children plus £5 times the number of adults. So 2x plus 5y is less than or equal to 90. Now, if x is greater or equal to 0 and y is greater or equal to 0, we shade out negative x and y. If x is less than 3y, we start by drawing the graph of x equals 3y. Now we can do this with a table. We can draw some boxes, choose values of x, let's say 0, 15 and 30, and we work out the values of y. Now if x is 0, y is also 0. If x is 15, then y is a third of 15, which is 5. And if x is 30, y is equal to 10. We can plot those points on the graph and join them with a straight line. Now we need to test which side has to be shaded. So we choose a point not on the line x equals 3y. Let's try x equals 5 and y equals 0. This gives us 5 is less than or equal to 3 times 0. Well, that's false. So we shade the side with 5 0. Now let's draw the graph of the inequality 2x plus 5y is less than or equal to 90. We start by drawing the graph of 2x plus 5y equals 90. We can make up a table choosing values of x. Let's say we choose x is 0 to 15 or 30. Now if x is 0, we have 5y equals 90, so y equals 18. If x equals 15, we have 30 plus 5y is 90, so 5y is 60, and so y is 12. If x is 30, we have 60 plus 5y equals 90. So 5y equals 30, so y equals 6. We can plot those points and join with a straight line. Now we want to know which side to shade, so we choose a point not on the line. Let's choose the origin 0, 0. So, substituting them in the inequality, we get 2 times 0 plus 5 times 0 is less than or equal to 90. That's true. So we shade the other side from the origin. And that gives us our graph. Now, let n be the number of people going. So we have n is equal to x plus y, and we want to maximize n. This equation is called the objective function. Now to maximize n, we draw the graph of x plus y equals 0, and then move the line as far away from the origin as possible. We're looking for the furthest point in the unshaded region. We are allowed points that are on unbroken lines. Now the furthest point is 24, 8. That means 24 children and 8 adults. So the maximum number of people who can go is 32.